Good morning. Today we will be doing the lesson I am not functioning properly. So our learning goals for today are to understand the difference between functions and relations, learn how to represent functions using the black box model, learn how to evaluate a function given an input, learn how to represent a function using function notation, and to understand and be able to apply the vertical line test. So the difference between functions and relations. First of all, we have to know what is a relation. Well, a relation is any graph, any expression that given an input, we get an output. So let's say if I plug in here, so 1, 2, 3, plug in x equals 2, I'll get an output of, well, y equals, let's say in this case, 2. So I put in an input and I get an output. If I put here an input of -1, I will get also an output. If I plug in here -2 as an input, so my x is always my input, my y always my output, I will get -1, I'll get -1.5, and I will get up here, I will get half as an output. 3 outputs, that's fine, it's still a relation. An input gives me an output. So then that is a relation. And you say, well, what is a function? Well, a function is also a relation. It's an expression, a graph, where an input gives you an output. But it's a special type of graph. It's a graph that has the characteristic that your input will give you exclusively one output. So let's say if I have a parabola like this. If I plug in here -1, I will get -1. If I plug in here, I don't know, 4, 1, 2, 3, 4, I will get here 1, 2, 3 as an output. No matter what I plug in, I will get exclusively one output. You see here in example A, when I plugged in -2 here as x, I got 3 outputs. Well, that's okay, but then it's not a function, it's just a relation, it's a simple relation. But when I have the characteristic, like in example B, that my function, my expression, my graph, for any input gives me exclusively one output no matter what, then it is also a relation, but it is also a function. So that is the difference between functions and relations. Relations is when you have an input, you get an output, but you can get many outputs. A function is a special type of relation when your input gives you exclusively one output. Now we'll be representing functions using the black box model. So what is the black box model? The black box model is when you have an input that goes into a black box, that something happens in here, and that will give you an output. So this is your input, this is your output. So what happens inside this box? Well, you don't really know. It's something that changes your input into your output. So let's say that I have an input of 2, and then my output is 6. What happens to make 2 into 6? That something happens inside this black box to transform 2 into 6. Well, then we know, well, 6 divided by 2 is 3. So I have to multiply 2 inside my black box. My input is being multiplied by 3 to get my output. So this is a function. This is a representation of a function. When you plug in a value, something happens to it. In this case, it's multiplied by 3, and then you get an output. The special thing about functions is that what happens, your black box is always the same. What changes is your input. You can choose your input to get varied output. So let's say if I didn't plug in 2, I plugged in 3, well then my 3 will be multiplied by 3, and then my output will be 9. So this is a function. It is a function, in this case, it's an easier way to understand it. It's represented in this black box model. When you plug in something, something happens to get you an output. And what's inside this black box is always the same. You can't change that in this determined function. What you can change is your input to get a different output. Now we'll be evaluating a function given an input. We know that a function, you put an input and then you get an output. Let's say I have a function f of x equals 2x. I want to evaluate this given an input. Well, this value is my input, and then this number here is what happens. So going back to my black box to understand this, the x from my f of x here is my input, and this 2 here is my black box. It's what's happening inside. It's just a different way to express this. So in this case, put in my input in x. So in this case, my input is x. And then my x is multiplied by 2. So this technically is my black box. It's my 2 multiplying my input. So then how do I evaluate a function? You see how in my black box, if I said that my input is 2, my answer is 6. If I said my input is 3, my output is 9. If my input were x, my output would be 3x. So this is exactly what's happening here in this case of my function. So my input here is x, so my output is 2x because my black box is times 2. So let's say I don't want x as an input, I want 2 as an input. So f of input 2 equals 2, and then instead of x, 2. So I'm multiplying in this black box my 2 by 2. So f of 2 equals 4. The black box model is a very interesting way to understand this. But then, so the concept is this. You plug in an input, you do what your expression tells you to do, and then you get a determined output, which in this case is 4. So that is how you evaluate a function. Let's say a more complex idea. F of x equals 16x squared minus 14. And you say, well, what is this? Well, it's the exact same thing, but I'm taking my input, I'm squaring it, multiplying by 16 and subtracting it by 14, and then that will be my output. The answer is my output. So in this case, since my input is x, my output is 16x squared minus 14. If my input were, let's say 4, f of 4, my output would be 16 times 4 squared minus 14. I can evaluate this. 4 squared is 16. 16 times 16 minus 14 will get me 242. So my f of 4 equals 242. If I input 4, my output will be 242 given this expression. That is how you evaluate functions. You take your input, put it in where once x was your input, but now you put in a number so you can actually calculate, and then you just calculate your expression. That is how you evaluate functions. So now let's represent a function using function notation. We have to understand here, let's say I have f of x equals 2x. F is just the name of the function. It's a name. So if I want to call it Mr. Bruno x, Mr. Bruno of x, sure, I can do that. But to make it much easier, you call it f of x. You just put any letter. It can be f of x, g of x, d of x, whatever you want. But put a number, a letter, it will make your life much easier. But what you have to understand, that is in just a name. Your x is your input, and this number is your black box. It's what you will be doing to your input. So that's 2, and then you'll multiply it by your input. Okay, that is how you represent a function. This is function notation. But then, well, why do I want to know this? Well, knowing all these concepts, you can create a function. You can create a function to get varied answers based on what you want. So let's say I open a bank account, and when I open my bank account, I deposit money, and the amount of money that I deposit, my bank gives me as a donation, as a present, 5% extra. So I want to create a function that represents how much money I will have in my account based on the amount of money that I deposit, this initial deposit. So my bank money in account, based on the money that I deposit, okay, so this is my name, so account is my name, technically. My input is the amount I deposit, equals, I get a 5% increase. So 5% is times 1.05 times the amount that I deposit. That is my function notation. So I take my deposit, multiply it by 1.05, which is the increase that I get, and then my output will be the amount of money that I have in my bank account. So I deposit a determined value. My determined value is multiplied by 1.05 inside technically my black box, and then my output will be all this. My output will be the amount that I have in my account. So if I plug in 100, if I put in $100 in my account, A of $100, which will be my input, equals 1.05 times 100. So I'll have, so A of 100 will equal $105. So if I plug in, if I deposit 100, I will have $105 in my deposited. I will have $105 in account. That is how you use function notation to solve problems. That is function notation. So now we'll be understanding and applying the vertical line test. So remember when I told you the difference between functions and relations? Well, you have to have a method to know if something is a function or a relation. So what you can use is the vertical line test. Let's say I have a graph here that goes something like that. How do I determine if this is a function or a relation? Well, if I draw many lines, just go drawing lines, I have to check, this is my vertical line test. If any of my lines that I draw crosses my graph more than once, that is not a function, it is just a relation. So that is how you do this. You just go drawing lines. So understanding this, well, what you're actually doing is you're putting a line determining your x input, and then your line will cross all your y outputs. If you never cross more than one output, then that is a function. So let's say if I have a parabola, if I draw many lines, my input will never cross my output more than once. So that is a function. What I like to do here is also I just go from left to right, passing my pen through the graph. And then if my pen hits my graph more than once at the same time, then that is a relation, not a function. So now let's go to some example. Let's say I have here f of x equals 13x minus 41. And I want to evaluate what is f of 0.2. So well, f of 0.2 will be 13 times 0.2 minus 41. So 13 times 0.2 will get me 2.6 minus 41. So f of 0.2 equals negative 38.4. That is my output given my 0.2 input. Now let's say another example. So the distance that I drive is a function of the amount of gasoline that I spend. So for every liter of gasoline that I spend, I can drive 16.2 kilometers. So what is the function that represents this expression? What is the function that expresses how much I can drive based on the amount of gasoline that I spend? Well, 1 liter will get me 16.2 kilometers. So my distance based on the amount of liters equals 16.2 times the amount of liters that I use. So what can I do with this? Let's say I want to know how far I can go. My question here, how far can I drive if I spend 12.4 liters of gasoline? Well, that means that if I spend 12.4 liters of gasoline, I input 12.4 liters of gasoline, then my output in kilometers will be 16.2 times 12.4. My answer for that will be 200.88. So D, 12.4 equals 200.88. If I use 12.4 liters of gasoline, I drove 200.88 kilometers. So now let's go for a last example. I want to use the vertical line test to evaluate the following graphs, if they're functions or relations. So let's draw my graphs here, something like that, something like this, and something like this. Well, using my vertical line test, I can already see here, I draw a line. Here I can already identify that my line crossed more than once. Relation. Okay. Draw a vertical line, bam, hit twice. Relation. And now if I draw my line, hit once, hit once, hit once, hit once, hit once, only once. It never hits more than once. My line never hits my graph more than once. So this is a function. So that is how you that is the end of my lesson. I'm not functioning properly. These are the homework exercise I would like you to do. Thank you very much.